毛巾、羽毛、小鸭鸭，水温刚刚好。泼泼水来搓泡泡，今天真是美妙。
And let's continue with the evolution of the periodic table. In 1865, John Newlands and Concord Choice proposed the law of octaves. Properties repeat every 8 elements. Then, in 1869, John L. Mayer organized elements by increasing atomic masses. Mendeleev arranged 63 known elements into columns and rows, with left blank spaces for elements that were not discovered at that time. Then in 1913, Henry Moseley arranged elements by increasing atomic number, not atomic mass, and that created the periodic law. Then in 2016, Hideto Ennio tries to add element 119 to the periodic table. New block of element that hosts elements 121 and 251. And last, in 2018, the UPAC publishes the most recent update of the periodic table.
So, hi, my name is Evan Alejandro Ortiz, and I'm going to explain about the evolution of the periodic table. The story of the periodic table starts in the ancient times when Plato and Aristotle made the theory of the four elements that they considered that the fire, air, water, and earth are made everything around us. And then in 1719, Lavoisier made a list about 33 substances, including the elements that we know that it is oxygen, argon, carbon, and gold, and proposed the nomenclature system. Then, 13 years later, Johannes Jacob Berzelius places the elements in alphabetic order, naming system of compounds. Then, 26 years later, Johann W. Dobeher Reiner classify classify the elements in triads with similar properties. Then in 1816 was created the first International Congress of Chemists was organized in Karlsruhe, Germany.
Hi, I'm Francisco Lara, and I'm going to explain the arrangement of the periodic table. First of all, you can find some columns which are called families or groups. The families are named after the representative element of each one. For example, the carbon family or the oxygen family. But they can also receive another name, such as noble gases, halogens, or alkaline earth metals. Then you can find you can divide it by two: the representative families and the transition elements. The most important are the representative ones, which are divided by 1A, 2A, 3A, 4A, 5A, 6A, 7A, and finally 8A, which are the noble gases. Then you can find the rows, which are called periods. So a period indicates you the energy level of an atom. If an atom is the seventh period, it's gonna reach the seventh energy level, and if it is in the third period, it's gonna reach the third energy level. That's it. Thank you.
So the periodic table is ordered in the increasing atomic number, and it is divided into groups or families. That is, the most important is the group A, because it is according to the valence electrons. For example, group 1A is 1 valence electron. Group 2A is 2 valence electron, and so that, and they are 8 groups. Then we have, there are more groups, there are 18 groups, but the group A is divided into 8 groups. And then it's in an horizontal way, it is the periods that are 7. And then we have the most important families that are the alkali metals, alkali earth metals, transition elements, halogens, and noble gases. Periodic table can also be divided into it's also classified into the electronegativity, that is from right to left, from up to down, with atomic radius, that is from left to right, from down to up, and the electronegativity can't be used in the noble gases because they are complete. And we also use the ionization energy, that is from right to left, from up to down. And also the periodic table has lanthanides and actinides that are in the lower part of the periodic table. And it is also classified, or can be classified, into metals, non-metals, and metalloids. And that my partner will explain that next. Thank you.
Hello, my name is Jose Valladares, and today I'm going to explain you a little bit about the classification of the elements on the periodic table. There are three classification of elements that are metal, non-metals, and metalloids. Uh, Almost all the periodic table has this differentiation between them with colors. Almost all the periodic table is made out of by metals because almost all the elements are metals. Also, the other part that is at the right, almost at the end, are non-metals, and between them there's like a little stair going from descending from the left to the right. Those are the metalloids. They have three. The three have different characteristics. For example, the metals are ductile, shiny, they have good conductivity, and they have high melting points. And as the name says, the non-metals have the opposite characteristics. They are not ductile, not shiny. Also, they have low melting points and all those things that differentiate them from the metals. The metalloids are like combination of these two because they have some characteristics of the metals but not that strong, and they have some characteristics of the metalloids. And that's why they are really good semiconductors, and they are used, for example, in the pieces of electronic devices. They are really good for that. Thank you.